I have been in Chennai for last 40 years. So, though my name has a Deshpande in front of it, it's only for the namesake. Of course, I am not a very good Tamil speaker, so I will continue in English. I thank Indo-American Chamber of Commerce and FAME for giving this opportunity to be in front of you. Basically, I am a born teacher, so I would like to share my experiences in terms of giving you some insight about what the industrial IoT or what the industry 4.0 for MSME is from my view of angle. I've been in industry for last almost, I came to Chennai for a job and then I started on my own. So I'm here almost more than 35 years working on industrial automation and the networking. This seminar, as it says, Industry 4.0 for MSME. Industry 4.0, there are a few points which are covered, I'm going to repeat them. Is the industrial revolution all about data from smart machines, smart assets, and analyzing it. Using the analysis for better efficiency, optimum utilization of these assets. Why fourth revolution now? The rapid evolution, why it didn't happen 5 years back, for example. Some reasons are covered up. Rapid evolution in technology leading to reduction in the size of memory, increasing the speed of internet and decreasing the cost of connectivity. Earlier, I know when I bought my first computer, my first connectivity was at 1.2 kbps, kilobits per second. And that's the reason those days we used to call WWW as World Wide Wait. Because it was slow. It was slow. Today we cannot imagine. Our phones are at Mbps. I mean, memory size wise, probably a hard disk which was there, which was 40 MB hard disk. We can't imagine those things. Okay. So all this has basically the reduction in the cost and reduction in the size has given the push to the development of taking the data to the cloud, analyzing the data on the cloud, because the analytical softwares are costly and they can be shared. So shared resources are always becoming cheaper. That's the reason Industry 4.0 is there today. This kind of a slide which brings, I didn't bring this slide to show you or explain you anything. These kind of slides make a small industry person or a medium industry person afraid of what the IoT is. So I'm not going to go through this slide. It is just a myth that there are a lot of things which are complicated in the Industry 4.0. Basically, Industry 4.0 is for make things efficient, new ideas, innovative ways of business, and stronger customer centricity. This is actually efficiency, innovation, and agility. The efficiency, innovation, and agility is not a monopoly of big industry or smart industry. These are the key characteristics of smart industry. Today, we have to move to become a smart industry. Everybody has to be smart. Every company has to be smart. Being smart is needed by every industry. Survival of the smartest. I think we should change survival of the fittest to survival of the smartest in terms of Industry 4.0 and for the manufacturing sector as such. Let's begin the journey to the Industry 4.0. Revolution it has to come from determined people. Machines can only help. Equipments can only give you support. The software can give you only support. It is not coming from within ourselves. The Industry 4.0 may not get implemented in your company. Having clear milestones and achievables well defined. So prepare your company for getting into Industry 4.0 mentally. That of course brings the fear that I have been being watched. Your operators are going to feel that they are being watched. Then I mean, this is going to be a transparent business, and in transparency, a lot of things are going to get exposed. So, making your organization ready for this journey is one of the most important things. Implementing step by step in small steps. Every step, there will be difficulties and there will be hurdles. We have to cross them with help of experts. Extracting data from the present machine, because you are not going to change the machine to make your factory smart. Whatever machine you have, you are going to use them. Visualizing this data and establishing the reliability of it. You cannot start big, you cannot start taking data from all the machines, and then establishing the reliability of the data would become a trouble. So start with that. And analyzing this data on the edge. To begin with, of course, if we have finances, we can always go for the cloud softwares. But to begin with, we can start doing the analytics on the edge itself. It's like you have machines, you have gateways, and you have software partners. Now the case studies. I would straight away jump to the case studies because that is going to make more sense. This is one example. This is done in Addison. I can show the name, that's not an issue. Here this was done almost about 4 years back. You have 10 machines which are connected. The category of that machine has been given there. Employee number will come there. The works you are able to see there, and this is a data which they are showing it on a big screen into the factory, so that it works as an incentive to them, saying that how much was the production needed by now and how much we have achieved so far. Figures figures what will come here are all going to be simulated figures. They are not going to be the real time figures. This is another production monitoring which again gives incentivize. If you feel you should ask any question, you can always stop me and ask me question, because I am going to show some of the examples what we have catered in last about 8 to 9 years. Now monitoring of multiple machines is possible. Here is one of the screen what we had developed for one of our customer. Here the machine photo comes, which machine is that, machine number comes, whether it is on or off, and then how much is the production, how much is the OE of that. OE is one of the very, very dubious word. It's a overall equipment efficiency, no doubt about it. But then some people have a different formula, some people have Y formula. Small changes are there. So we say that you give formula, we give the results. Our devices, edge devices, what we use are capable of giving all this data directly. You don't need anything additional than that. There are small softwares which are done on the edge devices. Your die casting machine, in case of die casting machine, you will need different parameters to be collected. Those parameters can be collected. Our devices, I'll come to what our devices are. The next example I'm going to take is for the injection molding machine. The data from the injection molding controller, or if very old machine exists, presently I'm sure there are not very old injection molding machines, they exist, but if they exist, the data can be taken from the sensors directly. We have facility for that, and this data can be shown. Now here, this data is not only visible locally, this data is available on your smartphone also. From anywhere in the world, it is possible. If you are allowing the connectivity to the outside world for your data, some people they don't allow. That's the reason if you are allowing is what I used. This can be, these all screens are possible. You will be able to see them wherever you have, provided you have the access for them. It is not available for anybody and everybody, and the access control is quite strict. Cyber security is quite important. As the industry 4.0 gets into shop floor, our all machines are going to get connected to internet, and that means the possibility of hackers getting into that increases. You are giving more possibilities of hacking because there are more machines which are connected. So we work with, the most important thing we all should work with is the highest cyber security. And there are various means of doing that. There are manufacturing methods for getting cybersecurity certified. One of the cybersecurity we always use is, though we have access to what you call cash withdrawal or something of that kind, always there is a next cross check which can come is the OTP. We give facility for OTP as well, so that your data or nobody can access your data so easily. Is the data important? I'm taking a cyber security in between my examples. Is the data important that somebody sees? Is there going to be any problem? Maybe there is going to be a problem. Your competitor might utilize it, but it's not a big problem if the data is being seen. But if somebody takes over the control of your equipment, then that's a trouble. 5 years back, if somebody would have said that my PLC is going to get hacked over internet by somebody, nobody would have believed it. But today we know that factories have been brought to standstill by attacking PLCs. So cyber security is one of the important factor which is must today. Okay, this is an example of a small manufacturing unit related to food and beverage, especially this is for the food. And you can see the entire plant, you can see the bar graphs, you can see the virtually whatever data you need, you can see it. Again, this data is also available for the general manager on his smartphone. This is another way of it. Hindustan Unilever has permitted me to show only this slide because there are many slides which are related to them. But anybody who is into industry where you need to see the data and realize whether is everything all right or not all right. Just at the glance you will be able to see there are some reds and there are greens. So you will be able to see what is a red and you will be able to work on it. Now access to be given to whom and for what data can be decided by you. It is up to you to decide whether MD should see everything or MD should see only the filtered data. He needs to know at the evening what is production, is there any downtime, is there any dispatches being stopped because of the downtime. Beyond that he need not know. Whereas a maintenance manager or a GM of that or whatever, or the person who looks after maintenance, because size can be different and then there may not be a manager, but he should know that the machine is down probably immediately. This is work what we have done for Biocon. Biocon, their manufacturing facility operates at the temperature which are -18 to -22. And temperature going beyond this limit is a trouble for them. Means the batch which would have been manufactured during the time when the temperatures were higher than -18 could get into trouble. Those batches might have to be rejected. And that's the reason this is being monitored very strictly. This is the old equipment what they have where the data is being gathered. We created an interface for that data, took it directly from that, and this is the entire day's graph for the temperature. Every day at a designated time, this graph gets posted on an email to their production man as well as the maintenance man. Apart from only manufacturing, apart from seeing only the OE, there are certain things which you need. You need to find, there are QCs involved, and then the QC also need to be monitored, stored, seen regularly. This one example is from the polyhose. They have again another equipment which online manufactures the pipe thickness, pipe OD. And that OD is being continuously monitored by our equipment, stored the data and shown it. If there are issues, again the alarm escalations are possible by email or SMS. This is for the pressure testing of the hose. And this is what is full factory's production data with the OE of each line. Again, this in the midnight, this is being created as an email from the edge device directly and posted across to the certain email IDs, and this data remains with them as a, you don't have to make any production sheet ready as such. You don't have to enter any data as such. Everything is being collected and put onto this. Apart from production QC, you have utilities, and you need to monitor the utilities. This is one example of utility being monitored. One of the, it's okay, this is for the generator and the fuel level of the generator. Many of our customers, those who use more than 500 megawatt, 500 kilowatt generators, many of them are leased by some company or the other. And the leasing company uses these kind of possibilities. In fact, this includes even the geolocations also. So if the generator is moved from one location to the other, the leasing company comes to know that that is what has happened. Another example for compressed air. Here, this was done for TVS Motor Company. And here the graph has been made to make sure that you know what's happening. Demand of the compressed air is being monitored here. And at the same time, the total flow being calculated, energy being calculated, integrated together, you are able to get the cost of the air yesterday. Of course, it's not 1.86. As I said, it's a simulated figure. So you have one after the other many examples, many applications which are being catered, and these things are possible only because Industry 4.0. Industry 4.0 and the equipments which are related to Industry 4.0. This can be implemented in your factory if your factory has one machine or two machines or 20 machines or 100 machines. It doesn't matter. Scaling up is very easy. Benchmark for good maintenance. One more point I want to highlight here is has been mean time between failure. We have been always trying to find out the stoppage of the machine, how much time it was stopped, and how many times it was stopped. At the same time, there is one more benchmark we should be as a OEM also and as a user also, is mean time to repair. And it is possible, and anything is possible. Now once you have a data, everything can be calculated and everything can be analyzed. Why do we do analysis? Why should we do such analysis? See, unless you analyze, you cannot improve. And unless you monitor, you cannot analyze. Now the analytics can give you, can lead our factories to really smart factories, and the AI, which is a big word, artificial intelligence, can be into the place. One of the biggest example we had been discussing earlier in the morning, one of the biggest example for AI, all of us use it, and that's a Google Maps. Google Maps gives you direction, not only gives you direction, but it tells you on a Monday morning, 9 o'clock at Mount Road, what will be the traffic. And it is only because the data has been collected over last 6 years, 7 years, and being analyzed. On a Sunday, if it is the 15th of August, which area would get crowded more? That data is also available. And it cannot come unless you have huge data being taken and analyzed. Once the data is there, you can do analysis by any means, any ways, any pivot, whatever you call. But you need data. Biggest question now is how about the investment in such a journey? We said, okay, we'll do the journey, but how much investments? As we have been seen that beginning can be small and it can be even a single machine. Investment really can be really small. Approximate our calculation per machine comes to approximately around 60,000. In this, what you get is a production count, hourly, shift-wise, daily, expected production and the actual production, running and stoppage time, alarms for prolonged stoppages, and data available on smartphone or a tablet or anything of that kind. This costing is indicative, but it starts somewhere at around 60,000 per machine. That means if you have two machines, whatever they are, if they are not highly sophisticated machines with sophisticated control, the data which is taken out from them will not be high. It will be related to only the production, time, reason for stoppage, and that's all, nothing beyond that. You may not know the spindle RPM, how much has happened. You may not know the tool life. For all these kind of things, you will need a machine which is really more smarter than that. what what we do is that we provide you a equipment which can get connected to any of the PLC, any of the controller which is on your shop floor. That means the biggest bottleneck. Anybody who has been working on the Industry 4.0 will know that data taking from a Siemens PLC is not easy. Data taking from a Rockwell PLC may not be that difficult, but it is not straightforward. Modbus has been utilized widely, but it is not available on the all equipments. We have all the protocols of all the PLCs which are there built into our device. And that is how we are able to say that the cost can be minimum. Journey ahead. Once we have reached the level where we are taking the data, we are monitoring it, we have understood the effect of 4.0, basic effect of the 4.0, then we can take this data to analytical and archival software for the future use. One day data is not useful for any production. One needs to take the data for really, really long time to give accurate predictions. You cannot predict a failure of a bearing just by saying that last 1 hour data. It's not so easy. You need to have the data over a period of time. What we offer is on-demand remote access, on-premise data monitoring, as well as the data collection to the cloud. These are the devices what we use. These are manufactured by a company in Sweden called HMS Networks. And we call them, these products, name them as, branded as E1, Eyes Watching Over Net. When there was no word called IoT or industrial IoT, way back in 2005, was the first time my office using these devices, I had put it onto the net. Every AC from the office, I could see it, whether it is on or off. What was the use? I knew that that manager has reached the office, if the AC is on. But of course, I used it for a demonstration. Those days it was magic. Everybody was thinking, and everybody used to say, oh no, Gokul, we are too small for this. This is not for us, or something of that kind. Now, as everybody has earlier said, that it is not a question of whether you want it or not. It's a question how much you can utilize it and improve yourself, how much you can become smart. Because survival of the smartest is what is going to count. One of the example which I didn't show earlier is a product called ROSS. This product is being floated by Thermax. This is taken from their website. So you can go to the Thermax website. Thermax is our largest customer as of today in India. They use approximately around 400 to 500 devices a year. They have a huge support room. Fortunately, they shifted from Pune to Chennai. They have a huge support room in Chennai where what we see in the movies that you are monitoring. So they are monitoring the entire worldwide, about, as of today, around 800 equipments. So they can see a pop-up coming from Germany. They can see a pop-up coming from Sri Lanka. They can see a pop-up coming from India, saying that there is a problem here. Before customer comes to know that there is a problem, and by the time they react on it, Thermax's engineering team is ready probably with the solution. Even they would have moved the spares which could have been required for that. Okay, Thermax can do it at that scale, but a small machinery manufacturer, a company called Expert in Bangalore, they manufacture exactly 12 machines a year, nothing more than that. Printing machines they make, they sell world over. They are known for their good printing machines. They also do the same thing. And their costs are not as high as Thermax. You don't need those costs. This is another thing what Thermax has talked about. Thermax talks about residual life analysis. Basis of all this is the data what they are collecting. Data what they get from every machine, every minute what they get data that has been taken and analyzed. Residual life analysis is being done by them. Okay. With this, I would say fittest of the smartest, Stay connected. My number is there in this slide. My email ID is there. Obviously, you can contact us anytime. We do seminars, we do trainings, we give trainings to students, we give trainings to professionals. Small, we do charge. Charge is not what is profitability for us, but spreading the word around and spreading the knowledge around is what we are interested in. Thanks a lot. Thanks ISCC again. Thank you.